13th May GFG question, we have to calculate the value of NCR, and here the formula is n factorial divided by r factorial into n minus r factorial. So the naive way to calculate this would be to have a factorial function, and you can calculate the factorial for n, you can calculate the r and n minus r individually, and then you can multiply, divide to get your answer, right? But if you carefully observe, this is the, and suppose the question is calculate the 10c3, okay? So this is the factorial of 10. Here it is factorial of r, which is 3, and here it is factorial of n minus r. So you can see there are so many redundant calculations that we do in our naive approach. For example, there is no need to calculate this 7 6. There is no need to calculate 7 factorial here because it is also in numerator and denominator. So it doesn't make any sense to calculate this, right? You're just going to multiply the value with the same and then divide again with the same. So all we need is these values, right? So the approach is here, we are going to traverse only 1 to r. The value of r here is 3. We are going to traverse from 1 to r, and for the numerator, what we are going to do, result, suppose result stores our answer, initially it would be 1, into is equals to, we are going to n minus I plus 1. So for example, the value of I would be from 1 to r, right? So suppose the first value of I is 1. So the value of n is fixed, it is 10, it is given in the question. 10 minus I, that is 1, 10 minus 1 plus 1, that is 10. So we got this value 10, and our result would be divided by 1 because the value of I is 1. Then I would be 2, so 10 minus 2 plus 1, that is 9, and our result will also get multiplied by 9 and also divided by 2. Then the value of I is 2, the value of I is 3, so 10 minus 3 plus 1, that is 8, and it will also get divided by 3, right? So all we did was compute only these three things. So that is the approach. And also consider this example. This is the exact same calculation, but the question is a little different. Here we are given the value of r as 7. So our this logic would end up doing this 1 to 7 traversal, and it will omit only 3 to 1 calculations, the factorial of 3 calculations. So basically we are omitting this thing, n minus r factorial, that is what we are omitting. But here you can observe we're still calculating some redundant things like 7 6 5 4, right? It is present in the numerator as well as here in the denominator. So how do we omit this? By this condition, if if the value of r, this 7, is greater than n minus r, n minus r is here 3, right? So whenever this condition occurs, we are going to update our r with n minus r. So our new r will become 3 again, right? 10 minus 7, that is 3. So we will end up doing the exact same thing that we did here, right? So that is the approach. First we are going to find the optimal value of r, and then we are going to just compute the result using this formula. So the complexity, time complexity, would be the big O of the minimum of big O of, let's say, n minus r or r, whatever is less, we're going to compute, we're going to traverse for that many times, and space is constant. And also there is an edge case. Whenever the value of r is greater than n, we have to return 0 because it is not a valid test case. And then if r is greater than n minus r, we're going to update the value of r in order to minimize the redundant calculations. Then traverse from 1 to r. Let's have a result variable. N minus I plus 1, and result would be divided by I, and then we return result. Right, it is working completely fine. Okay.